There's just one other thing that you need to add to your notes today regarding the law of sines, and that is an area formula. When we're finding the area of a triangle, then we know that it's 1/2 the base times the height. And as long as we have a right triangle where we're given the base and we're given the height, then that's fine. But if we're given an oblique triangle, then the height part is usually not labeled, and we have to find that using some other method. Well, let's use the law of sines to come up with a formula for the height. Go back to the way we derive the law of sines. We'll just use angle A here. We said that sine of angle A is equal to opposite, which would be our h, because we're working in that right triangle, over hypotenuse, which is c. And then to solve for h, we multiply both sides by c, and we get c times sine A is the height. This height is the height of the triangle. This height is also the height of the triangle. So I'm going to replace this expression for height, 1/2 b, because b is still my base and it's opposite angle b, so that's good. And then for height, I'm going to have c sine A. And that's one version of area of a triangle from the law of sines. Now, any mixture of letters is fine as long as you have an A and a B and a C. If we had dropped our perpendicular from some other angle other than B, then our letters would be rearranged, and we might have area is equal to 1/2 A times B times sine C. Or another version of this would be area is equal to 1/2. We've already used B and C as the sides and A and B as the sides, so that leaves A and C. A times C, we have to have all three letters, so we're going to have sine B. Those are your three versions for the area formula when you have an oblique triangle and you're given two lengths and the included side. I'm sorry, two lengths of the sides and the included angle.